Hey everybody. Today what you have is a clip from a bigger video on solving systems using elimination. This is going to focus in on having to multiply both equations to manipulate them to have the same coefficient. I hope this helps you out. Best of luck. Okay, you can see the system that I've given you in F, and there is equation 1 and equation 2. And now we take a look and we're like, oh no. For me to change a 2 into a 5, I'm going to have to multiply by a fraction or a decimal. For me to change a 4 into a 3 or a 3 into a 4, I'm going to have to do the same. And so now we may be thinking, oh, so now I've got to introduce some fractions that I'm going to multiply by. My numbers are going to get ugly. You know what? This is no better than substitution. I want to make sure that we have a good idea in our head. If we can manipulate one equation, then we can manipulate two. And so we don't have to use fractions in order to use elimination. It just means we're going to multiply both equations by a value. Now, I'm going to do this kind of in two different ways because I just want us to see something really quickly. And I don't think that either one way is better than the other. I could take equation 1, and if my focus was on the x's, getting the same number in front of my x's, then one of the easy things I could do is multiply equation 1 by 5 and equation 2 by 2. And notice, in both of those cases, my equations would both have 10 x's. The same number of x's, and now I could eliminate my x's. But I could have also multiplied equation 1 by 4 and equation 2 by 3, and that would have given me 12 y's, and therefore the same number of y's in both equations, and I could have eliminated my y's. That when I'm taking a look in this system, either of those methods, either of those decisions would have basically got me to the same thing. And that's why I would argue I don't think that there's one way that's better than the other. Multiplying by 5 versus multiplying by 2, multiplying by 3 versus multiplying by 4, those are all going to keep my numbers relatively the same. You know, they're not blowing numbers up and making them huge. So what I want you to do is take one of those actions. Multiply equation 1 and 2 to eliminate your x's, or multiply equation 1 and 2 to eliminate your y's. And let's see if we match up in the end. Okay, pause the video now, give it a shot. Okay, I'm going to work my way through. Just because, let's say, 5 is a bigger number, I'm going to choose to multiply and get rid of my y's. So I'm going to multiply equation 1 by 4 and equation 2 by 3. It makes no difference. If I do that, I'm going to create two new equations. If I focus in on multiplying equation 1 by 4, then that is going to give me an 8x plus 12y is equal to 20. I just unsimplified that equation. That now becomes equation 3. Well, in order to get the same number of y's, I'm now going to multiply equation 2 by 3. That gets me 15x plus 12y equals 48. I unsimplified equation 2, so that needs a new equation number. There's my equation 4. Okay, I now have 4 equations, but I am focusing in on my manipulated versions, 3 and 4, to now solve my system. I did that to make my decision to eliminate my y's, and since I like having positive coefficients, I'm going to take equation 4 and subtract equation 3. That then, when I go through and I subtract them, that's going to give me a 7x equals a 28. Oh, and I love getting numbers like that because now I get an integer again. Nice. Notice here's an instance where had I taken equation 3 and subtracted equation 4, I would have had negative 7x equals negative 20, and it just would have introduced negatives, and now I was able to avoid that. Okay, I'm going to wrap my solution around because now I need to sub equation 4, or sorry, x equals 4 back into, and as I stated previously, go back into one of your originals because you know those things are true. So I'm going to sub it back into equation 1 because equation 1 just has smaller numbers. When I do that, I'm going to get 8 plus 3y equals 5. So 3y equals negative 3 and y equals negative 1. State my final solution, my x value and my y value, and you now just solved a system that required manipulating both equations to use elimination. Take a look back at your original system. Imagine rearranging those equations to isolate one of your variables. You're going to get fractions. It's going to slow you down. You may make some mistakes. I think even with having to manipulate both equations, to multiply both of them, you're still faster using elimination than what you would have been using substitution. So I'm telling you, when you have a linear system, you want to make your default method of solving elimination. Don't be a substitution junkie and always use substitution. But when you have a linear system, those two equations, both of the same degree, you want to make elimination your default method. Okay, let's play around with a couple more. We'll see how well we're doing with elimination. Okay, I want you to take a look at the system I gave you in G. And yes, that system became a lot uglier when I gave it to you. But we're not going to really take our time going through G. I just want to point out to you a couple things in using elimination. Well, you should notice that you have a system of equations right now that are unsimplified. Notice, take a look at equation 1. If you expanded all those brackets, you would have the ability to collect some like terms. Same thing in equation 2. So really all that was given to you was an unsimplified system. That should not affect how you go through to solve. I just want to point out a couple things. First off, I am going to simplify both of those equations first. So I'm going to start maybe with equation 1, and I can expand my brackets. And really, we hope that with that process, you can pretty quickly get down to a simplified version of equation 1. And you can do it where it's like perfect every time. Like almost, like yes, you can make a human error mistake in there, but I'm really hoping that expanding some brackets and collecting like terms, we don't make mistakes with that anymore. And so that equation that we just came up with, 4x minus y equals 9, that can be an automatic, like you expect that to be perfect, the best version of equation 1. So I'm hoping then that we could do the same thing with equation 2. And you could go through, and I'm going to go quickly and expand in. We could clean up what we have on both sides. We get to this part where now, because we have a negative in every term, I may take a moment to just say, hey, I'm going to divide both sides of my equation by -1, and I'm going to clean up that equation just so I don't have to deal with so many negatives. But same thing as I stated earlier, you're so good at going through and expanding brackets and collecting like terms that you have such confidence that that new version of equation 2 is perfect. Okay, I want you to focus in on those two versions of equation 1 and 2. Because those are going to be the versions that you're going to use elimination on. And I'm not going to go through and solve this system using elimination. I hope we could see probably the best action for us would be to take equation 1 and multiply it by 2, because then you could add together your two equations and eliminate your y's. What I want to talk to you about with this system is, once you've solved for x, okay, so we multiply equation 1 by 2, we get a new equation 3, we then take equation 2 and equation 3 and we add them together, we eliminate our y's, so we solve for x. You now have this decision, and I'm just making up a number here, x equals 5. It's not x equals 5, but let's just say it's x equals 5. Now I've told you, take your x equals 5 and sub it back into one of your originals. This is a case where we have to kind of weigh, okay, how confident are we that we haven't made mistakes versus the ease of our work? And here's one where I would argue to you, you should be so confident in everything you did in gold on the screen that you shouldn't have to sub it back into one of the originals, because then you're going to have more work to do. That you should be good to sub it back into one of the orange versions of those, the gold versions, I should say, because you are so confident that you haven't made any mistakes there. And subbing it back into one of those versions will make your life easier. So keep that in mind when you end up getting a system of equations where those equations are not simplified. Okay, just something to consider as you move forward. Okay, now I want to throw a doozy at you.